Okay. I'm trying to do it. I've got worked a couple times in prep. I haven't had it quite work out here. I'm trying to record what's happening so that I can post it for when people are absent, when people have questions at home at night. So, trying to take a video of what's happening here. Okay, so the third type of reaction. So there was 5. We did 2 yesterday. We probably won't finish this one today. Say what? Yeah, the third one's a little bit more complicated. Okay, so we're going to talk about the third one is called single replacement. What do you think happens in single replacement? Look at the name. How many things? 1. What does it do? It replaces. So one thing replaces another. Okay? So one element replaces another. So that means I need something to be replaced in and something to do the replacing. I'm going to need 2 reactants. Okay? One for it to be replaced in and one to do the replacing. So my reactants are going to be an element and a compound. And the products will be a different element because it got replaced, and a different compound because you replaced that element with its neighbor. So here's an example. Sodium and potassium chloride makes potassium and sodium chloride. So if you look what happened between the first one and the second, between the reactants and the products, what happened was the Na replaced the K. It kicked the K off. The K was kicked off by itself. So why they call that single replacement? One thing replaces. Okay? So why did Na replace K? Well, you have to replace something you're like. K was a metal, Na was a metal. The two that are like each other are going to replace each other. The two that like each other are not going to end up next to each other. Metals won't end up next to metals. Okay? Because metals can replace metals. Fluorine, a nonmetal, when it reacts with lithium chloride, doesn't replace the lithium, it replaces the fluorine. Nonmetals replace nonmetals. So when I think about the types of reactions, an analogy comes to mind. And that analogy is dancing. Because to me, a combination reaction is like the start of a dance. The music starts playing, and separate things come together to make a couple on the dance floor. Elements come together to make a compound. That's combination. Decomposition is the end of the music. Music stops, the couple that was together go their separate ways. Start off with a compound, end up with 2 elements. Single replacement is cutting in a dance. You got a couple out on the dance floor, taps them on the shoulder. Mind if I cut in? Cuts in. I start off with one person by themselves and a couple. When I'm done, I end up with a different person by themselves and a different couple. Is it reasonable? Okay, so that analogy shows what's happening with the pieces, coming together, falling apart, replacing. Okay, here it is in terms of pictures, the same thing just with some pictures. Okay, so I had sodium plus chlorine, or potassium chloride. The sodium kicks the potassium out of the way, and I'm left with sodium next to chlorine and potassium by itself. Now, when fluorine's dancing, they're twins, right? So in order for fluorine to replace, it's got to find two couples. You call both the chlorines so that they can end up diatomic. Single replacement. Make sense? So metals replace metals, and we're going to treat, and if hydrogen's first, it's acting like a metal. So metals can replace hydrogen. So yeah. Yeah, no, it won't show up because it's acting like a nonmetal. Hydrogen versus hydride. Gainer versus loser. Okay? Because remember, hydrogen can do both. Lose its electron to BH plus, gain an electron to look like helium and BH minus. Okay? So Mg plus CuSO4. Okay? Well, actually, we're at the point now where I can actually show you this stuff. Here's some CuSO4. Or the test tube. Here's some magnesium. Where that is. Here's some stirring. Okay. Now the copper 2 sulfate was copper 2 sulfate was blue, magnesium was a metal. We'll let that sit for a minute, see what happens. Something's going on. So let's do the reaction right here. So magnesium pushes off the copper. So magnesium takes copper's place, so it ends up next to sulfate. And the copper ends up by itself. So first I did what the name said, single replacement. Now I have to deal with, did I write the formulas correctly? Copper's by itself. Does it need a little 2? Okay. Magnesium is 2 plus. Sulfate is 2 minus. Is that the right formula for magnesium and sulfate together? Yeah. So that's the right formula. So first I put the pieces together, then I use charges and figure out the little numbers, then I balance. This one balanced pretty easy. They don't always balance this easy, but this one did. Okay? So what would I see? Well, my CuSO4 was aqueous, right? That was the blue. So if this reaction happens, that blue should disappear, and I should make an orange solid. Copper's an orange solid, right? Notice I'm not nearly as blue as I was before. Okay. See down at the bottom of this. Now, it's orange at the bottom. So it's not just a bunch of letters on the screen. This says that magnesium is going to make copper, it's going to make pure copper. That's why I'm going to add it. What happens is the magnesium sulfate dissolves, stays dissolved. So I had copper sulfate dissolved and put in magnesium. I end up with magnesium dissolved, magnesium sulfate dissolved, and copper metal. What about Zn plus H2SO4? Zinc and sulfuric acid. Okay, I recognize this as single replacement because I have an element by itself and a compound, a person by themselves and a couple. Okay? The Zn is going to try to replace what? It's a metal, so it's going to try to replace the positive piece, the H. So the Zn is going to replace the SO4. And H is going to be by itself. Can H be by itself? H can't be by itself. It gets a little 2, one of our diatomic. It's a gen. Sulfate, we said, was 2 minus. What's the charge on zinc? See, I can't tell from the table, but we're supposed to just memorize it. Here's one of the 3 we're supposed to memorize. Zinc is always 2 plus. Well, that equals 0. So I got the little numbers fixed. Now I need to balance it. This one balanced easy. They don't always balance easy. So this says that if I put together zinc and sulfuric acid, I should make zinc sulfate and hydrogen. So here I have sulfuric acid. Some pieces of zinc. Everybody see it bubbling away? Okay. Yeah. I want to catch those bubbles. Catch those bubbles. What are those bubbles supposed to be? They're supposed to be hydrogen, aren't they? So we'll be able to come back and see if those are hydrogen. Okay. Fe plus CuSO4. So the Fe is going to end up next to the SO4. It's going to be part of the couple now. Metals first. And the copper is going to be by itself. Now I need to figure out those little charges. Does copper get a little 2 next to it? Sulfate's 2 minus. What's the charge on iron? Correct answer is, I have no idea. Because iron can take on more than one charge. So in this case, I'd have to tell you what charge it got. That make sense? You can't figure it out without me telling you. I told you I'd always provide it for you. So let's say iron makes a 3 ion. Fe3, SO4 2. Fe3 plus, SO4 is 2 minus, so I'd have to crisscross and get Fe2, SO4 3. I'd have to tell you it was going to be 3 plus, but once I did, you could write that. So that means I need 2 Fe, so I put a 2 there. 3 SO4s, so I put a 3 there. That gives me 3 Cu, so I put a 3 there. And 2 Fes, 2 Fes, 3 Cus, 3 Cus, 3 SO4s, 3 SO4s. So, you said this is hydrogen. Is it? Notice how much water condensed on the inside. They got to really fill up hydrogen, and you can see the water. So there's hydrogen and oxygen makes water. Look here. Notice the blue's gone. The blue was the dissolved copper. Dissolved copper's not there anymore, right? Now, solid copper is sitting at the bottom, just like I said. It's not just a bunch of letters, it actually happens. What we predict oftentimes happens. Okay, we talked about this before, but now it's going to be important. In single replacement reactions, you want to think of water as hydrogen hydroxide. Because metals only replace one of the hydrogens and leave hydroxide behind. Because if metals are going to take off an H+, what are they going to leave behind? Their choice was between O2- and OH-. They leave behind OH-. Only one of the H's will come off. Treat water a little special. HOH. So, calcium in water. Hey, we've seen that reaction before. We watched that one say calcium was pretty active. Okay? That one bubbled and fizzed. What was going on? Calcium is going to replace hydrogen. So calcium is going to end up next to hydroxide, and hydrogen is going to be by itself. So first I do what the name says, single replace. Then I figure out the little numbers on the bottom. Does H need a little too? Yes. Hydroxide is 1-, calcium's 2+. Does that add up to 0? Nope, so I have to have 2 hydroxides. And then I have to balance it. And actually, look how balancing gets easier now that I have hydrogens and hydroxides. I need 2 hydrogens and 2 hydroxides. So I need 2 waters. Now that makes it easier to balance. Okay. Now, with decomposition and combination, you had to take my word that it was going to happen. Okay? Single replacement, you'll be able to decide whether it'll happen. Turns out some metals are more active than others. And more active replaces less active. So here's how the analogy works with that. If a senior, because we're cutting into the dance, right? So if a senior went up to a freshman and said, "Mind if I dance with your date?" There's probably going to be a different partnership on the floor. But if a freshman went up to a senior and said, "Mind if I dance with your date?" There's unlikely to be a change, right? That's what I mean by more active, less active. The senior is always going to replace the freshman. The freshman is never going to be able to replace the senior. Got the idea with there? Well, the same thing happens with metals. The most active replaces the less active. Less active will never replace more active. Okay? So there's a list. On page 266 of your book. Here it is. Here's what it says. And actually, here's a copy of that list. So you keep it with you. You don't have to memorize this list. It'll be provided for you. This is a list of who's a senior, who's a freshman. Okay? The seniors are at the top of the list. Lithium. The freshmen are at the bottom of the list. Gold. These are at the top of the list. Replace everything below them. Higher on the list replaces lower. So you find the two elements, find the one that's by itself, compare it to the one that's not by itself. One by itself is higher, the reaction happens. If one by itself is lower, it doesn't happen. Seniors replace freshmen. Freshmen can't replace seniors. The analogy works really well for that. That's why I like it. So, if the element by itself is higher, it happens. If it's lower, it doesn't react. So we can look at a few of the reactions that we did. Okay? I put magnesium by itself into copper sulfate. Magnesium is higher than copper on the list. So we would predict there would be a reaction, but we got a reaction. Right? Zinc and hydrochloric acid. Zinc is here. H is here. It happened. Hydrogen. Hydrogen got replaced. Okay? So prediction would happen. Okay? So that's how I use the list. Okay? There's one little thing, if you read that carefully, they talk about hydrogen specifically. Because hydrogen can show up in two places. Hydrogen can show up in acids, and the list works perfectly for acids. But you can think of water as a committed couple. That senior's going to have to be a lot harder, a lot higher on the list in order to do it, because you've got to break up a committed couple. So only the most reactive react with cold water. That would be the top list up there. Reacts with cold water and acids. So everything reacts with acids, only some of them react with water. So the metal is going to kick the hydrogen off and end up next to hydroxide. So I'm going to have a metal hydroxide and hydrogen gas. Then there's the next group. Next group will work if you have it in steam, but it won't work with cold water. You have to put a lot of energy in it already. Okay, so the most active, react with cold water. Next group, active but not active enough for cold water, react with steam. Next group, won't react with water at all, will only react with acids. From H2 on down, not only will they not replace the hydrogen, but if you bubble hydrogen in, it's going to replace them. Because now we're lower than hydrogen. Right? So if you put that hydrogen gas in, it'll replace them and they'll end up by themselves. Yeah. Now those ones that are below hydrogen, notice it doesn't say they're non-reactive, it says that they react with oxygen. There's also a section on oxygen, react with oxygen, react with oxygen, react with oxygen, react with oxygen. and then unreacted. That lowest on the list won't even react with oxygen. But let's look and see what those elements are. The ones that don't react with oxygen or hydrogen. Silver, platinum, and gold. What do we use silver, platinum, and gold for? Jewelry, rings. Is that the only thing we use them for? And you don't want to rust, but what? Money. Okay. Money. That's what they made money out of. Okay. Why are those worth money? Because they don't change. How would you like a coin made out of magnesium? That magnesium is going to oxidize over time. It's going to react with oxygen. If your jewelry has some copper in it, because over time your skin turns green. That's because that copper gets replaced along the way. Okay? So we make jewelry out of them because they don't rust or tarnish. We also make our money out of them because they don't rust or tarnish. Because gold was by weight. You don't want its weight to disappear, and you wouldn't trust it if its weight went up. Right? We want things that aren't going to react, that are always going to be the same weight for money. So that's why they get used for jewelry, because they don't tarnish. They get used for money because they don't change. Because there's things that are rarer than those three things, but they all react with stuff. So, Al plus H2O liquid. Before you take the time to figure out what this is going to make, first you need to figure out, is it going to happen? Aluminum, my list is up here. Hydrogen's down here. So that says it's higher, it should replace it, except it's water. And it says aluminum's in the second group that only reacts with steam. Right? So if I put aluminum in water, what do you expect to see happen? Nothing. You guys store stuff in aluminum foil all the time. It gets wet. Does the aluminum disappear? Because that's what would happen, right? If the aluminum reacted with the water, it would disappear. Now you do have to be careful when you're cooking with aluminum. Because Al plus H2O gas means it's steam. So it's going to happen. So the Al, and I'm going to rewrite this as Al plus HOH to remind myself that the Al only replaces one of the H's. So the Al ends up next to OH, and H ends up by itself. Okay? So I put the pieces in the right place. Now I worry about the little numbers on the bottom. H, does H get a little 2 at the bottom? Yep. Al is 3 plus. OH is 1 minus. So that doesn't add up to 0, so I need to do this. And here's where the real benefit comes into doing it as H and OH. My H's come in packages of 2. My OH's come in packages of 3. How many HOH's I'm going to need in order for that to work out? Where are 2 and 3 going to meet each other? At 6. So if I put 6 waters here, that'll force me to put 2 aluminums to get my 6 hydroxides, 3 hydrogens to get my 6 hydrogens, and I have to have 2 in front of the aluminum along the way. A different way of looking at how to balance it. I knew I was going to end up with 6 waters. Because that's the first place 2 and 3 are going to run into each other. So what if you put aluminum with an acid? Is there going to be a reaction? Well, it's an acid. Everything higher replaces an acid, so there's going to be a reaction. The aluminum is going to replace the H and end up next to Cl. Cl is going to get a new partner. H is going to be by itself. Can H be by itself? It's 2. Aluminum and chlorine. Aluminum's 3 plus. Chloride's 1 minus. So it's got to be AlCl3. Balance-wise, we end up the same thing. My HCl is 1 of each, and I've got 2 H's and 3 Cl's. So I'm still going to run into each other at 6. So I'm going to have to put a 6 here, a 2 here, and a 3 there. And I'll put a 2 in front of Al. This you have to worry about when you're cooking. Okay? Because if you cook with aluminum pans, the aluminum disappears over time if it's an acid. I found that out because when I was in high school and college, the way I paid for my college was I made pizzas. Okay? And I worked for a little place where we made our own pizza sauce. So every day I would take and pour jugs of tomato puree and tomato juice and spices and stir them up in this big aluminum stock pot, those big ones, and then pour it into containers so we could use it. Made sauce every day. After a few years of working there, I noticed the sauce pot was leaking. And it was leaking down from the side near the bottom. I looked to see why it was leaking, and it was because there had been a hole eaten all the way through that aluminum over the course of the 20 years they'd used that stock pot. Okay? But the aluminum, that tomato sauce is acidic. So you never want to cook tomato sauce in aluminum foil because the acid will eat the aluminum and end up with a little bit more aluminum ions than you want to eat. And it'll make your pans go away if you cook in an aluminum pan. I found it out the hard way. When part of the pan disappeared and it started to leak. So, Fe plus CuSO4. You can write this balanced equation, but it's always smart to check, is it going to happen first? So is Fe going to replace Cu? Well, Fe is here, Cu is here. Is Fe higher than Cu? Yes. Is this reaction going to happen? Yes. What's it going to make? Well, we run into the same problem we ran into before. You see you get a little 2? No. Charge on sulfate is 2 minus. What's the charge on iron? You don't know. Because iron gets on different ones. You can't assume it's just going to be the same as copper. It could be 3 plus, it could be 2 plus. We don't know. I'd have to tell you which one it is. To make our life easier, this time we're going to make it 2 plus, because that makes balancing this really easy. But it's entirely possible that it could have been 3 plus as well. And how would we tell? Because 2 plus and 3 plus are different colors. One of them's orange, the other one's green. So that's how we'd be able to tell which one it is. Okay. So, oops. What about PB and KCl? If I put some lead into some potassium chloride, there's PB, there's K. Is PB going to be able to replace K? No reaction. Yep, still working. Okay. That's what metals do. What about non-metals? Metals replace metals, non-metals replace non-metals. For us, though, we're going to limit ourselves to just the halogens. So we're only going to think about simple replacement for the halogens. Chlorine, chlorine, bromine, iodine. Now, on my list, it was the activity series of metals, right? Chlorine, chlorine, bromine, and iodine are not going to show up on this list. There's got to be a list for nonmetals too, which is more active, which is least active. Well, actually for us, luckily for us, it's actually the same order on the table. Fluorine's the most active, iodine's the least active. And I put it on here. I put it down here for nonmetals down there for you, but you really don't need that one because it's the same order as the table. Fluorine will replace everything below it. Iodine cannot replace anything. So iodine tends to end up alone. Fluorine ends up in compounds. In fact, is you never find fluorine by itself. It's always diatomic as a gas, and as soon as it runs into something else, it steals their electrons, makes a new compound. You can't store fluorine very easily, because anything you put it into, it tends to steal the electrons from. Okay. And so higher replaces lower. So so we have to change a little bit. We have to figure out what it's going to try to replace. It was metals replacing metals. What is fluorine going to try to replace? Fluorine's going to replace chlorine, not hydrogen. Is that going to happen? Is fluorine higher than chlorine? So fluorine's more active, so it's going to happen. So the F is going to end up next to H. H is going to get a new partner, and Cl is going to be by itself. Can Cl be by itself? It gets a 2. H is 1 plus, F is 1 minus. So HF is the right formula. Then I have to balance. 2 F's means I have to put a 2 in front of HF. 2 H's means I put in front of 2 and H in front of 2 HCl. 2 Cl's gives me Cl2. Extra tough? Br2 plus KCl. So when you see a little 2 on your element, think of it, oh, that's the second kind of replacement. It's going to replace the second element. That's what 2 says, oh, the second element is what's going to replace. This reaction going to happen? Well, bromine is below chlorine. So bromine's not strong enough. Software is not going to push the junior off. Okay? So this is DNR, does not react. And that's the third type. So, homework 9 is practice on this. That's what the activity series there. Not all of these are single replacement. First decide what kind it is. Should be identifiable as combination, 2 elements, or they'll tell you. Decomposition, 1 compound, falling apart. Single replacement, 1 element, 1 compound. One of each. Which decide which type, do what the name says. If it's combination, combine them. If it's decomposition, fall apart. If it's single replace, replace singly. Okay, so the front side, 1 through 20, and then we go 21 through 25. Oh my goodness, there's a whole backside. No. The whole backside, it's the same as 180 on the front. So you don't have to do the backside. Although, after you've done it, see if it's the same answer so that first one, 2 elements. What are 2 elements going to do? Don't forget, every time you gotta figure out if you've got that right formula on the other side. Don't just put the pieces together, those charges. Combination, okay, combination. So you put those two together, you can probably just write that formula. One compound. The only way to change this all apart to its own. Okay, that's what we learned yesterday. Have a good one.